All right, guys, welcome to the applications of normal distribution, section 11.7. The standard normal distribution is a normal distribution with mean of 0 and the standard deviation of 1. We have explored that if we look at the examples that I did above. And also the definitions that were listed in my previous videos. Now, I'm going to reiterate some information. Since the area calculations for a normal distribution are really difficult, tables have been compiled that list the areas in a certain proportions of the standard normal curve. But they only work from when the mean is 0 and the standard deviation is 1. And that table is called the standard normal distribution table, as we used for chapter 11, section 6. So when we have raw data, we're going to use a clever trick to change any normal distribution to 1 with a mean of 0 and a standard deviation is 1. To convert our raw data into standardized data, we will use what is called the z-score for the given values, as we did before. But there is a way for us to find the z-score for our raw data, and it is called the z-score formula. Now, the z-score formula is defined below. Z equals to x, which is your data value, minus x bar, which is the sample mean, divided by the standard deviation. You will also see your z-score formula written as z is equal to x, which is your data value, minus mu, which is the population mean, divided by lowercase sigma, which is going to be the population standard deviation. Basically, when it comes to finding your z-score is equal to your data value minus the mean divided by the standard deviation. So keep that in mind. It is data value minus mean divided by standard deviation.
I didn't understand that.
My phone is listening to me as I'm recording videos. Anyways, we are going to be looking how to find the probability for a normally distributed variable. But in this case, we are not given z-scores. We are given raw data. And remember the rules for the directions. If the area is shaded to the left, the probability we receive is the final answer. If the area is shaded to the right, we are going to subtract the probability we get from the z-score from 1. And if the area is shaded in between, after we find the probability from the given z-scores, subtract them. The bigger probability minus the smaller probability. Okay. Now, it says here, based on data in the EPA study released in 2016, the average American generates 1,606 pounds of garbage per year. Let's estimate the number of pounds generated per person is approximately normally distributed. So when you see normally distributed, we know bell-shaped curve with a standard deviation of 200 pounds. Find the probability that a randomly selected person generates A, between 1,250 pounds of garbage and 2,050 pounds of garbage per year. B, more than 2,050 pounds of garbage per year. All right, cool. What I'm going to do is I'm going to draw my bell-shaped curve. And the reason why I now can draw it is because it said the variable is approximately normally distributed. And remember, in the center of my normal distribution, I place my mean, which is 1,606 pounds. And these values that goes to the left and to the right side of my bell-shaped curve represents the standard deviations, the distance away from the mean. Moving one standard deviation to the right, I'm increasing by 200 pounds. That is going to be 1,806, 2,006, 2,206. Move to the left, decrease. 1,406, 1,206, 1,006. Okay. It says you want to find the probability that a person has between 1,250 pounds of garbage and 2,050 pounds of garbage per year. So 1,250 will go somewhere right here. And 2,050 will go right here. And then we're going to shade in between. Okay. Now, we need to find the probability of this area. However, if you notice, these are in z-scores. This is raw data, actual data values. Therefore, we have to convert each of these values into z-scores. How do we do that? Well, we're going to use the z-score formula. Now, it doesn't matter which one you use, but z is equal to the data value under examination minus the mean divided by the standard deviation. We're trying to find the probability between 1,250 pounds, which I'm going to call my first X, and 2,050 pounds, which is going to be my second X. So I must convert those raw data values into standardized values by using the z-score formula. So let's convert 1,250 pounds into a z-score. Z is equal to that data value that's under examination, 1,250, minus the mean. The mean, which is the average, is 1,606, divided by the standard deviation of 200 pounds. And remember, we want to round our z-score to two numbers after the decimal. So let's subtract. Open that up. Let's clear this nonsense. 1,250 minus 1,606. That equals to negative 356. So negative 356 divided by 200. Let's divide that by 200. We get negative 1.78. All right. Let's do the same thing for the next data value. That is going to be 2,050. So z equals to 2,050 minus 1,606 divided by 200. Let's go ahead and do that. So that's going to be 2050 minus, scroll down a little bit, 1,606. That equals to 444. Let's divide that by 200. And we get 2.22. So we have a z-score of 2.22. After that, let's find the probability of each of those z-scores. The probability that z equals to negative 1.78 and the probability that z equals to 2.22. So let's stay on the positive side briefly. Z equals to 2.22. That is going to be right here. Scroll down. That's going to be 0.9868. Oops, wrong file. And then let's go to the negative side. Z equals to negative 1.78. Negative 1.7. 8 is over there. That appears to be 0.0375. Because the areas are in between, you must subtract bigger probability minus the smaller probability. So the probability that an American generates between 1,250 pounds of garbage and 2,050 pounds of garbage per year is equal to 0.9868 minus 0.0375. Let's subtract those values. Let's first clear the calculator. So 0.9868 minus 0.0375. And that's going to equal to 0.9493. So we can say approximately 95% of Americans will generate between 1,250 pounds of garbage and 2,050 pounds of garbage per year. Why about 95%? Because I can move the decimal over 2 units to the right, which makes that 94.93%, which is about 95%. Okay. Let's answer the next part of the question. It says, we want to find the probability that a randomly selected person has more than 2,050 pounds of garbage per year. This more than represents right shading. And remember, when it is shading to the right, you must subtract that probability of the given z-score from 1. Now, when it says more than 2,050 pounds of garbage per year, we found the z-score already for 2,050 pounds. The z-score for 2,050 pounds is 2.22. And the probability of the z-score of 2.22 is right here, 0.9868. So to answer question B, the probability that a randomly selected person will generate more than 2,050 pounds of garbage per year that is going to equal to 1 minus 0.9868. And that's going to equal to 0.0132. So the answer part B was very convenient for us to do. Because once again, you have to follow the same steps. You have to transform this data value into a z-score using that process. Once you have the z-score, you are going to go to the standard normal distribution table and find the probability of that z-score. After you find the probability of that z-score, because it is shaded to the right, more than means right, you must subtract the probability from 1. All right, guys, that is it, and I'll see you in the next one. Take care.